Alright gang, I want to make a quick video to help you out with your retest this Wednesday. So this is take number billion and something. So first time back at this, taking a little while to get it working. So here we go. So the first thing is we want to name line L, or name line N in a different way. So there are a number of ways we can name it. We can call it EC, and just make sure you put the line symbol above it. You could call it line AC as well, just again the line symbol above it. And then the next one, ray through B, so that would be some ray, that would go through B, so it could be EB, and just make sure there's a ray symbol above it. Or you could even call it DB, there would be a ray that would go through B as well. Alright, any line segment, so there's so many on here, so any 2 points that are on the same line segment there, so just make sure you put a little segment above it. Or even EC, again with the little line segment above it. Name an angle that has EC as one of the sides, so we could use this as one of the sides, and then this angle here would be the angle. So this angle would be angle CEB, or you could go the other direction and it would be angle BEC, and it would represent that same angle. You could even do another angle, over on this side that has that ray EC as well, so that could be angle DEC, or the other direction, angle CED. Alright, so that should be good on that one. Wow, more troubles. Okay, so let's see if this thing will let me get to the next problem. Okay, here we go. Good. Alright, so we want to find RS. So to be able to find that length, we need coordinates. So let's get that down here. So R has coordinates -2, 3. And S has coordinates, it looks like 1, 2, 3, 4, 2. Alright, so if we want to find length, RS, then it's a big ol' square root, and we're going to subtract the x's, so it's going to be 4 minus a -2 squared plus, then we're going to do 2 minus 3 squared, and then we just work that out, so big ol' square root, 4 minus a -2 is actually 6 squared plus 2 minus 3 is -1 squared, and so that's going to be 36 plus 1, which is the square root of 37. So that would be the length. The next question, we want to find out if L and M are the same length, so we need to find those lengths. So let's do LM. Let's find the coordinates first. So L looks like it has coordinates -1, -4, and M looks like it has coordinates 1, 2, looks like 2, -2. Alright, so let's do the same thing. So distance formula, LM equals big ol' square root, so we're going to do 2 minus a -1 squared plus, then we're going to do -2 minus a -4 squared. So 2 minus a -1 is actually 3 squared, so that's square root 3 squared plus, and then -2 minus a negative, that's actually -2 plus 4, so that is 2 squared. So this is going to be equal to 9, square root of 9 plus square root of 4, which is square root of 13. So let's try to find the other length now. So the other one is JK. So JK, we're going to need some coordinates here. So let's see. For J, the coordinates are, looks like -4, 4. So -4, 4. And K looks like it's -2, 1. Okay, So then we're going to do the same thing. We're going to do the distance formula. So jk would be equal to big ol' square root. So it's going to be -2 minus a -4 squared plus 1 minus 4 squared. And let's work that out. So it's going to be -2 plus 4, which is actually 2 squared. And then 1 minus 4 is -3, but that's going to be squared as well. So that's 4 plus 9, which is the square root of 13. So when we compare those two, we're like, hey, they're the same, so we just say, are they congruent? We would say yes, they have the same length. So you could lay one on top of the other. Alright, next one. Let's see if I can get to that next slide. Come on, get me there. This thing's being really tough. Alright, so name the angle in 3 different ways. So one way we could do it is, this one could be angle B, just because there's only one angle there, so that's appropriate to just have one letter in that case. We could also do angle ABC, or we could do angle CBA. So any of those would be great. Whoops, didn't mean to do that. Sorry about that. Alright, let's see if I can get to the next one. Okay, so this one, constructing the angle bisector, really we just, you'll probably need to just look at the marks here. We did great on that one, so I don't think people are going to be doing too much of retesting on that one. But you put the 2 marks on the sides here, put your compass here, and put the marks here, and then change your compass so it goes here and here, and then you'll put a mark there and a mark there. And then wherever they intersect, you'll put a dot, and then take your straight edge, and it'll go straight through. Alright? Alright, see me individually if you need help on that one. Alright, let me see if I can get to number 5. Alright, write a rule. Now for this one, you can tell that it's going, the x-coordinate is going from 5 to 2, and you're thinking, oh, that looks like we're subtracting 3 from it, which it is. And then the y-coordinate looks like it goes from 3 to -4. So we just want to be able to state, how to write that rule. So the way we're going to do it is we're going to say that x, y becomes, and we're going to say you're going to have to subtract 3 from the x's, so it's going to be x minus 3. And then from the y's, it looks like we're going to have to subtract 7. So we're going to say y minus 7, and then you just put parentheses. So this is one great way to write the rule. Alright. Okay, let me get to 6 here. Alright. A rotation is a rigid motion. Yes, it is. So when you rotate a figure, the size and the shape stays the same. So that's how we can determine a rigid motion. Size and shape stays the same. Size and shape stays the same. Okay. Alright, let's see if I can get to the next one. Okay. Alright, we want to see what the image of this point here actually would be if we do this to it. So do this. When I say do this, it looks like we have to take the x-coordinate and multiply by 1/2, and then we take the y-coordinate and multiply by 3. So if we take the -2 and we multiply it, so -2 we multiply it by 1/2, and then with the -3 we're going to have to multiply that by 3. And whatever that is, that's going to be our new point. So let's say -2 times 1/2, so that would be -1, and then -3 times 3, and that would be -9. So the new point would be -1, -9 under this transformation. Okay, next one. we want to find the image of triangle ABC after we do this to it. So this is just a translation. So we're going to take each of the x coordinates, we're going to subtract 2. So this one, 2, 7, would be, now we would subtract 2, and then we have to also add 7 to the y values. So let's see if we can do that. So we're going to subtract 2, and then we're going to add 7. So when we add 7, that's going to take us, off the darn thing. So if we add 7 to this, that would be 14. So we would be here, and then we'd be up here at 14. So this would be our new point. It would be A prime, way up there at 0, 14. Okay. Then the new point for B, it's right at 4 right now, so then we'd move over to the left, so that would be 2, and then we would add 7, so if we add 7 to that, then it would be right at 5. So we're going to say 2, 5 is where that point would be. So that's right there, and that would be B prime, and that would be 2, 5. And then the next point would be this -3. So if we go to the left a little bit, 2 units, we're going to go, that'll take us to -5. So then we want to also add 7 to the y value. So if we add 7, that would be 2. So this is going to be -5. So 1, 2, 3, 4, 5, and then that's going to be up here at 2. So this would be C prime, and then we would connect those dots, and that would be our new triangle. It's been translated up, and it is a rigid motion, so yes, because it's the same size and shape. Okay, number 9, or whatever number this is, write the rule. So it looks like you have to kind of analyze the points to see what what happened to the points. So you can see -2 becomes -4. So you might be thinking, okay, I'm doubling. 4 goes to 8, so that it confirms that it looks like it's doubling. -2 to -4, again doubling. So we're going to double the x's, and then it looks like the y's actually stayed the same. Oh no, they didn't, just kidding. So 2 went to 1, and then 0 is going to stay at 0, and then -2 looks like it went to -1. So the y values look like they're being cut in half, and the x coordinates look like they're being doubled. So what we're going to say is we're going to say that xy became, and we're going to double those x's, so we're going to say 2x, and then it looks like the y's are multiplied just by a half, so then it'll be 1/2 y. Is this a rigid motion? Didn't mean to do that. Is this a rigid motion? Yes, it is, because the size and the shape, oh, just kidding. No, because we were multiplying by 2, and then we're multiplying by a half, and so the size is going to be different. So we're going to say no. So the size and shape would be different. Alright? You can multiply by things as long as you multiply by 1 or -1, so it doesn't change the size. Alright. So next one, so we can get to the next problem here. Alright. So this one, we're going to try to apply some angle addition and segment addition to these next couple problems. So I'm going to label them a little bit. So AB should be x minus 4, and BC should be 2x minus 7. And it says the whole thing, AC, is 25. Well, doesn't that make sense that you add up the two pieces and they equal the whole thing? So that's how we set up our equation. So x minus 4 plus 2x minus 7 equals 25. And then we use our algebra skills to solve this. So we add up our x's, so that's 3x, then -4 and a -7, that's actually minus 11, equals 25. And then we add 11, we're trying to get the x by itself, so we got 3x equals 36, and x equals 12. So let's make sure we answer the question. So x is 12, so that would be that part. Then it says find AB. Well, AB, remember, is equal to x minus 4. So then we plug that x value in. So we got 12 minus 4. So that means that AB is actually 8. So AB is 8. And then BC is, let's see, BC was 2x minus 7. So let's put that in there. So that would be 2 times 12 minus 7, 24 minus 7, which is, let's say, 17, yeah? Good. All right, next one. We're getting there. We're getting there. I'm hopeful I'm going to be able to finish this without any technical difficulties. Okay, so that was segment addition postulate. So now angle addition postulate. So I would label these. So BOC, that's this angle here. So that's x plus 3. And then AOB, that's this one, and that's 4x minus 7. And it says that the whole thing, this whole thing, the big angle, is 21. So that whole thing is 21. So doesn't it make sense if you add up the two pieces of the angle that it would equal the whole thing? I hope so. So we're going to add those together. So that would be 4x minus 7 plus x plus 3 equals 21. And again, we use our algebra skills. I'm sure you brought some good algebra skills to the table here. If not, we can work on that. So 4x plus x, so that's 5x. And then we have negative 7 plus 3. So that's going to be negative 4 equals 21. Then we're going to add the 4 over. So that's 5x equals 25, and so x equals 5. So we want to make sure we answer the question. Let's see, what were we looking for? AOB. So AOB, angle AOB, is listed as 4x minus 7. Well, the x is 5, so we're going to go 4 times 5 minus 7. 20 minus 7, so that's going to be 13. So that angle is probably 13 degrees there then. What postulate can be used? This is the angle addition postulate. So angle addition postulate. Again, the last one was segment addition postulate. All right. Okay, let's see here. There's no AC in this school on Sunday, so ugh, I'm hot. All right, so hypothesis and conclusion. I think this is the last one. So the hypothesis is just whatever comes after the if. So this is the hypothesis. And then, so just make a little note, that's hypothesis. And then the conclusion is just whatever's after the then. So conclusion right there. So don't include the if and the then, and you should be in good shape. I think that's it. Tell me, thank you, Lord. Am I done? Let's see. Ooh, okay, done. All right, I hope you do awesome on this. If this helps you, then I would do this. I could do this every single time. Okay, I could do it before the module quiz. You could do amazing the first time. All right, later, skaters.